The morning air along the casino front hung heavy with cordite and dust on the 15th of April, 1944. German artillery officer Hauptmann Friedrich Weber stood in his sandbagged observation post, field glasses pressed against tired eyes, scanning the valley below. For months, his battery of 17-centimeter Cannoni 18 guns had dominated this sector, their shells reaching farther than any Allied artillery piece the Germans had yet encountered. They called it the Cannoni 18 Germany's Pride, Krupp's masterwork. With a maximum range of nearly 18.5 miles, it had given Wehrmacht gunners an invisible shield, a zone of untouchable superiority. American and British batteries had to push dangerously forward to answer German fire, making themselves vulnerable, exposed. Weber had grown accustomed to this advantage, had come to rely on it the way a swordsman relies on his greater reach. Then something changed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The first shell arrived without warning, a distinctive whistle that Weber's experienced ear recognized as wrong, different. It screamed overhead with a velocity that shouldn't have been possible, shouldn't have existed. The explosion erupted 300 meters behind his observation post, cratering the supply road with a violence that made the ground buck beneath his boots. Before Weber could process what he'd witnessed, 5 more shells followed in rapid succession, each one landing with mathematical precision along the German artillery positions. Weber's hands trembled as he lowered his field glasses. Those shells hadn't come from any known American gun. The trajectory, the range, the sheer destructive power, it defied everything German intelligence had told them about American artillery capabilities. For the first time in his 3 years of service on multiple fronts, Hauptmann Weber felt the cold touch of technological obsolescence. What Weber couldn't know in that moment of shocked realization, was that he'd just experienced the opening salvo from America's newest and most powerful field artillery weapon, the 8-inch gun M1. And somewhere in the fog of war and bureaucratic intelligence gathering, German high command was about to receive a very uncomfortable education about American industrial might. To understand how Germany arrived at this moment of reckoning, we must first understand what the 17-centimeter Cannoni 18 represented to the Wehrmacht. In 1941, when Krupp delivered the first production models, it seemed like the answer to every German artillery commander's prayer. The gun evolved from the earlier 21-centimeter Mercer 18, sharing the same carriage but firing a smaller, faster projectile that could reach unprecedented distances. The statistics were impressive, by any measure. A 138-pound high-explosive shell launched at a muzzle velocity of over 3,000 feet per second, capable of striking targets 18.4 miles away. The weapon employed an innovative double recoil system. The barrel recoiled conventionally, but the entire gun platform also slid backward on rails, dramatically reducing stress on the carriage and increasing accuracy. German gunners could traverse the weapon 360 degrees once properly emplaced, making it remarkably flexible for counter-battery work. But the Cannoni 18 came with significant costs. Each gun weighed over 23 tons in traveling configuration, requiring heavy half-track tractors to move. Setup time consumed hours. The weapon had to be broken down into 2 loads for transport, then reassembled at the firing position. The dual recoil mechanism, while technically brilliant, demanded constant maintenance and precise calibration. Most troubling, Krupp, and later Hanomag could only produce these complex weapons slowly. By war's end, just 338 examples existed across all German forces. Still, for German artillery officers fighting in Italy through 1943 and early 1944, the Cannoni 18 provided a crucial advantage. American artillery, while numerous and well-supplied, couldn't match its reach. The M1A1 155mm gun, called Long Tom by American troops, reached only 13.7 miles. The 8-inch Howitzer M1, not to be confused with the 8-inch gun maxed out at approximately 11 miles with its high trajectory fire. This range disparity shaped tactical doctrine across the Italian front. German batteries could sit comfortably behind defensive lines, protected by terrain and distance, lobbing shells onto American positions with near impunity. American counter-battery fire required pushing guns dangerously forward into positions where German observers could spot them, where Luftwaffe aircraft might strafe them, where a sudden German breakthrough could overrun them. The psychological impact of this advantage cannot be overstated. German artillery crews, already professional and well-trained, developed an almost casual confidence. They'd studied American tactics, knew American weapons, understood American limitations. Intelligence reports confirmed what experience taught. American artillery doctrine emphasized weight of fire over individual gun range, quantity over quality. The Americans would throw dozens of guns at a target that Germany might engage with a single battery. Let the Americans have their numbers, German commanders reasoned. German guns could shoot farther, and in modern warfare, range meant survival. But in the sprawling complexity of global war, intelligence has a way of aging poorly. While German artillery officers in Italy tracked known American weapons with comfortable familiarity, American engineers back home had been working on something new. The story of the 8-inch gun M1 began not in 1944, but 25 years earlier, in the aftermath of the First World War. The Westervelt Board convened in 1919 to assess American artillery needs for future conflicts. Brigadier General William Westervelt and his committee studied the lessons of the Great War with meticulous attention. One conclusion emerged with particular clarity. America needed a heavy field gun capable of engaging enemy artillery at extreme range, yet mobile enough for modern motorized warfare. The specifications seemed almost fantastical for the era. A bore of approximately 8 inches, actually 203 millimeters, a projectile weighing around 200 pounds, maximum range of 35,000 yards, nearly 20 miles. Most ambitiously, it had to be road transportable, capable of being towed at 25 miles per hour, yet broken down into loads light enough that existing roads and bridges could handle them. No other nation had such a weapon. Germany's heavy guns from the Great War were railway-bound monsters or required elaborate concrete emplacements. France's heaviest field pieces topped out at shorter ranges. Britain's arsenal emphasized different weight classes. The Westervelt Board envisioned something unprecedented strategic range in a tactical weapon, but vision and reality diverge in peacetime militaries. Design work limped along through the 1920s at low priority, always subordinate to more pressing needs, always vulnerable to budget cuts. The Great Depression of the 1930s nearly killed the program entirely. Not until 1940, with war consuming Europe and American rearmament accelerating, did serious development resume. Engineers at Watervliet Arsenal and Watertown Arsenal attacked the technical challenges with renewed urgency. The primary obstacle was simple physics. To hurl a 200-pound projectile 20 miles required enormous barrel pressures and velocities that created catastrophic wear. Early test barrels literally wore out after a few hundred rounds, their rifling eroded, their accuracy degraded beyond acceptable limits. The solution emerged through metallurgical innovation and careful balancing of competing factors. The final design used a barrel 46 calibers long, that is, 46 times the diameter of the bore. High-quality steel alloys extended barrel life to acceptable levels. A sophisticated recoil mechanism absorbed the violent rearward thrust. The carriage, adapted from the 240mm Howitzer M1 project, provided stability and allowed the weapon to share transport wagons with its larger cousin. Testing through 1942 and 1943 revealed persistent problems. Barrel wear remained higher than desired. Accuracy at maximum range proved inconsistent. The high-velocity shells traveling at over 2,700 feet per second at the muzzle imposed stresses that sometimes caused premature shell failures. But by late 1943, with American forces bogged down in Italy and facing the prospect of assaulting Fortress Europe across the English Channel, the army couldn't afford to wait for perfection. In January 1944, the 8-inch gun M1 was officially standardized. Production orders went to Watervliet Arsenal for gun tubes, Hannifin Manufacturing for recoil systems, and Watertown Arsenal, Bucyrus Erie, and S. Morgan Smith Company for carriages. The target: equip specialized heavy field artillery battalions with 4 batteries each, 4 guns per battery, 64 guns total per battalion. These units would provide corps and army-level fire support, engaging enemy artillery, hitting headquarters, destroying bridges, demolishing fortifications. But even with production prioritized, American industry struggled to build these complex weapons quickly. Each gun represented thousands of man-hours of specialized labor, precision machining, careful assembly. By war's end in Europe, only 139 complete systems would exist, a tiny fraction of American artillery production, but each one a potential game-changer. The first 8-inch gun M1 units began forming in late 1943. The 575th Field Artillery Battalion stood up at Fort Bragg, North Carolina, drawing experienced personnel from existing artillery units. Crews trained intensively on the new weapon, learning its quirks and capabilities. Unlike the rapid-firing 105mm Howitzers or even the Long Tom, the 8-inch gun demanded patience. The barrel had to be depressed to loading elevation for each shot. The recoil was severe enough that even with spades dug in, the entire weapon shifted slightly with each firing. Maximum rate of fire topped out at 1 round per minute, sometimes less, under combat conditions. What the gun lacked in rate of fire, it made up for in reach and punch. The standard M106 high-explosive shell weighed 240 pounds, nearly twice the weight of a Long Tom projectile, and carried a bursting charge that could excavate a crater 15 feet deep and 30 feet across. At maximum range, the shell's flight time exceeded a minute, giving it time to rise to altitudes where thin air offered little resistance, then plunge down with devastating terminal velocity. In April 1944, Battery B of the 575th Field Artillery Battalion deployed to the Anzio beachhead, attached to the 698th Field Artillery Battalion. Battery A went to the Casino front, attached to the 697th Field Artillery Battalion. For the first time, American forces in Italy possessed artillery that could reach beyond German guns, that could strike back at the Cannoni 18 positions that had dominated the battlefield for so long. The guns arrived without fanfare, without announcement. German intelligence, focused on tracking the movements of known American divisions and the build-up for inevitable amphibious operations in northern France, missed their significance. Aerial reconnaissance photographs showed new artillery positions, but the guns looked superficially similar to existing American pieces: tube, carriage, crew, ammunition. Without close inspection or captured examples, intelligence officers had no reason to suspect these were anything special. This oversight, this gap in German intelligence, was about to have profound consequences for Wehrmacht artillery doctrine. Because the 8-inch gun didn't just outrange the Cannon 18, it outranged it by approximately 2.5 to 3 miles, creating a buffer zone where American guns could fire with impunity while German batteries sat helpless, unable to shoot back. For Hauptmann Weber and thousands of Prague German artillery officers like him, the comfortable certainties of 3 years of warfare were about to shatter. The gun they'd trusted, the range advantage they'd exploited, the tactical superiority they'd assumed, all of it, rested on foundations that American industry had quietly undermined. The revolution in artillery warfare along the Italian front didn't announce itself with dramatic proclamations or obvious markers. It began with confusion, with German forward observers reporting shell impacts from impossible directions. with artillerymen calculating backward trajectories that couldn't exist according to their intelligence briefings. Battery commanders checked and rechecked their maps. Perhaps American guns had infiltrated closer than reconnaissance suggested. Perhaps new positions had been missed. But when German counter-battery fire reached out to expected ranges, they found nothing. The American guns firing those long-range shells simply didn't exist where German doctrine said they should. The truth emerged gradually, pieced together from multiple encounters across the casino sector. Those weren't long toms firing. Those weren't 8-inch howitzers lobbing high-trajectory shots. These were different. A new weapon, a new capability, a new threat. American shells began arriving on German positions from distances that the Kanone 18 could match, but not exceed. And when German guns attempted to fire back, they found themselves just barely able to reach the American positions if they fired at maximum charge, if they accepted reduced accuracy, if they were willing to accelerate barrel wear. The Americans, meanwhile, could fire comfortably below their maximum range, conserving their tubes, maintaining accuracy, choosing their targets with leisurely precision. In the counter-battery duel that followed through late April and May of 1944, German artillery batteries began dying, not in dramatic explosions or immediate catastrophes, but through steady attrition that German gunners couldn't answer. American observation aircraft, Piper L-4 Grasshoppers and Stinson L-5 Sentinels, floated lazily above the battlefield, seemingly immune to German interceptors thanks to Allied air superiority, calmly adjusting fire onto German gun positions. The 8-inch shells arrived with terrifying consistency. Unlike smaller caliber American artillery that might take dozens of rounds to knock out a hardened position, the 8-inch shells often succeeded in a handful of shots. A near miss from a 240-pound shell could flip a multi-ton gun carriage, collapse bunkers, crater roads. Direct hits simply erased guns from existence, leaving behind twisted metal and cratered earth. German batteries began displacing more frequently, abandoning their comfortable positions, sacrificing their carefully surveyed firing data, accepting reduced accuracy in exchange for survival. But displacement was costly. The Kanone 18, it required hours to break down, move, and set up again. During those vulnerable hours, the battery was combat ineffective, unable to provide fire support, unable to answer American attacks. American intelligence officers, analyzing prisoner interrogations and captured documents, began to understand what they'd achieved. The 8-inch gun hadn't just added another artillery piece to the inventory, it had fundamentally altered the tactical calculus. For the first time in the Italian campaign, American artillery had wrested range superiority from German guns. The intelligence breakthrough came in early June 1944, though not in the manner German high command would have preferred. Near the town of Velletri, southeast of Rome, elements of the American 36th Infantry Division overran a hastily abandoned German artillery position. In their rush to retreat, Wehrmacht gunners left behind more than just their guns. They left behind documentation, technical manuals, and, most critically, several American shell fragments that had landed nearby during recent counter-battery exchanges. But the real prize came 3 weeks later. On June 23rd, near the Trasimene line north of Rome, American forces from the 2nd New Zealand Division captured an intact 8-inch gun position after a swift armoured thrust cut off the battery's retreat route. 4 complete 8-inch guns, their transport wagons, ammunition, fire control equipment, and even the unit's records fell into Allied hands before anyone could destroy them. German intelligence officers arrived within 48 hours, having commandeered what little remained of Luftwaffe transport capability to reach the site. What they found both impressed and disturbed them in equal measure. The preliminary examination happened in a barn near Chiusi, with Oberst Heinrich Brenner leading a team of Wehrmacht artillery specialists and weapons engineers from the Heereswaffenamt. Brenner's report, filed on July 2, 1944, and later captured by American forces at the end of the war, reveals the German assessment with remarkable candor. The document opens with a stark admission. The American 8-inch gun represents a significant advancement in mobile heavy artillery that exceeds current Wehrmacht capabilities in several critical areas. The Germans approached their examination methodically. First, the basic specifications. Caliber: exactly 203 mm, 8.0 inches. Overall length in traveling configuration: 37 feet. Combat weight with carriage: 32,000 pounds. The barrel itself measured 46 calibers in length, significantly longer than the Canoni 18's 45 calibers, though both used similar barrel length to bore ratios. The carriage immediately caught German attention. It employed a split-trail design nearly identical to the American 240mm Howitzer's mount, suggesting correctly, as Brenner noted, that American designers had deliberately created component commonality. This approach meant simplified logistics, interchangeable parts, and reduced training time for crews who might operate both weapons. Germany's Canone 18 shared its Mercer Lafette carriage with the 21cm Mercer 18, so the concept wasn't foreign, but the Americans had executed it with greater attention to ease of manufacturing. What truly struck the German examiners was the weapon's performance envelope. Maximum range with the M106 high-explosive shell, 32,584 meters. Brenner's report converts this to 35,635 yards, but the more damning comparison appears in his conclusion. This represents approximately 5,000 meters, nearly 3 miles greater range than our 17cm Canoni 18, and approximately 6 to 7 kilometers more than our most common core-level guns. The shell weight provided another unpleasant surprise. At 240 pounds, the American projectile carried nearly double the explosive payload of typical German artillery in the same range class. The Canoni 18's 138-pound shell, impressive in its own right, seemed almost anemic in comparison. More explosive meant larger burst radius, greater fragmentation, improved anti-personnel effects, better performance against field fortifications. Brenner's team measured the muzzle velocity by examining the chamber pressure indicators and barrel wear patterns, calculating approximately 2,700 feet per second. This extreme velocity explained several puzzles that had bedeviled German forward observers. The shell's flat trajectory at medium ranges made it difficult to distinguish from direct-fire weapons. The tremendous impact velocity created distinctive crater patterns. The flight time to maximum range exceeded 60 seconds, allowing the shell to climb to altitudes where air resistance diminished, extending range beyond what simple ballistics would suggest. The recoil system drew particular praise from German engineers. America had employed a sophisticated hydraulic pneumatic mechanism that absorbed the gun's violent rearward thrust, without requiring the elaborate dual recoil rails of the Canoni 18. This simpler system meant reduced maintenance, faster emplacement, and fewer mechanical failures. 4 trail spades, 2 at the trail ends and 2 behind the carriage, transmitted recoil forces directly into the ground. The Germans noted that American crews could emplace and remove these spades in minutes, whereas the Canoni 18's recoil system required careful leveling and alignment. Transportation arrangements revealed another American advantage. The 8-inch gun broke down into 2 loads like the Canoni 18 barrel on one wagon, carriage on another, but the Americans had designed their transport in wagons with pneumatic tires and sophisticated suspension systems. This allowed road speeds approaching 35 miles per hour when towed by the M4 high-speed tractor or improvised prime movers. German transport wagons, still employing older suspension technology, struggled to exceed 20 miles per hour without risking mechanical failure. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But Oberst Brenner's most significant observation came not from the weapon's technical specifications, but from the broader context it revealed. His report notes, American production philosophy clearly differs fundamentally from German approaches. This weapon sacrifices theoretical maximum performance for manufacturability and reliability. The barrel life is reportedly shorter than desired, perhaps 1,000 rounds. The accuracy at extreme range is adequate, but not exceptional. Yet these compromises allow simpler production, easier training, and faster deployment. Most concerning is the implication that if America can produce such weapons in quantity, despite their complexity, our intelligence estimates of American industrial capacity require substantial revision upward. The examination of captured ammunition provided further insights. The Americans used two-part ammunition projectile and bagged propellant charges similar to German practice. Two charge options existed: the M9 green bag for medium ranges with improved accuracy and reduced barrel wear, and the M10 white bag for maximum range firing. This flexibility allowed battery commanders to conserve their tubes when long range wasn't necessary. Fuse options included the M51A three-point detonating fuse, which could be set for instantaneous detonation or delayed penetration, and the M67A3 mechanical time fuse for airburst effects. The Germans recognized these as sophisticated, reliable designs, not revolutionary, but executed with the kind of manufacturing precision that American industry had made routine. The fire control system, examined through captured documents and equipment, revealed another dimension of American artillery superiority. The 8-inch gun employed standard American fire direction center procedures, but with enhancements for long-range shooting. Careful meteorological data, wind speed and direction at multiple altitudes, temperature gradients, air density fed into firing solutions. Forward observers, often airborne in light aircraft, adjusted fire with impressive speed and accuracy. German analysts noted that American artillery doctrine emphasized centralized fire control at battalion and even higher levels. Multiple batteries could concentrate fire on a single target within minutes, then shift to new targets with minimal delay. The 8-inch gun fit naturally into this system, providing the reach to engage distant targets while maintaining the coordination that made American artillery so effective. By mid-July 1944, multiple copies of Brenner's report circulated through Wehrmacht artillery commands. Reactions varied from denial to alarm. Some officers dismissed the 8-inch gun as a minor threat after all. Only a handful existed in Italy, and their slow rate of fire limited their tactical impact. Others recognized the weapon as emblematic of a broader problem. American industry could design, test, and field advanced weapons faster than German intelligence could track them. The psychological impact on German artillery crews proved harder to quantify, but no less significant. Gunners who'd grown accustomed to range superiority now faced the prospect of being outranged, of taking fire they couldn't answer, of dying to an enemy they couldn't reach. The Canone 18 remained a superb weapon by any objective standard, but superiority is relative. What had been Germany's longest-reaching mobile gun was now merely second best. German responses varied by unit and circumstance. Some batteries attempted to close the range gap by displacing forward, accepting greater vulnerability to accept greater reach. Others relied increasingly on indirect approaches, firing at predicted coordinates rather than observed targets, accepting lower accuracy in exchange for avoiding counter-battery detection. Still, others simply avoided engagements where American 8-inch guns might be present, ceding tactical initiative to preserve their guns. The broader strategic implications troubled German high command more than the tactical details. If American industry could produce complex heavy artillery like the 8-inch gun in meaningful numbers, and intelligence reports suggested 8 or 9 battalions might eventually deploy what else might be coming. How many other American weapons exceeded German intelligence estimates? How thoroughly had German assumptions about American industrial capabilities been wrong? These questions became more urgent as summer 1944 progressed. The Normandy invasion had revealed American artillery superiority in shocking detail. Wehrmacht units in France reported being smothered by American shells in quantities that seemed impossible. Forward observers called down fire from dozens of batteries simultaneously. American guns displaced and repositioned with bewildering speed, their truck-mounted mobility making German horse-drawn artillery seem positively medieval. The 8-inch guns' deployment to the European theatre accelerated after the Normandy breakout. By September 1944, additional batteries arrived in France, joining the 575th Field Artillery Battalion, already blooded in Italy. These guns participated in the reduction of fortified positions along the Siegfried Line, where their long-range and heavy shells proved ideal for counter-battery work. During the Battle of San Malo in August 1944, 2 batteries of the 243rd Field Artillery Battalion's 8-inch guns supported the 83rd Infantry Division in reducing the German garrison. Battery C advanced to within 2,400 yards of the citadel for direct fire engagements, firing 540 shells at gun ports, openings, and weak points in the fortress walls. The high velocity of the shells, unusual for siege work, allowed unprecedented precision against small targets. Unfortunately, the bombardment also started fires in the town itself, though these were initially attributed to German defenders. In the Siegfried Line campaign, 8-inch guns adjusted by aerial observers destroyed 2 bridges over the Rohr River, cutting key German supply routes. The guns' combination of range, accuracy, and hitting power made them ideal for interdiction missions against targets beyond the reach of lighter artillery. But perhaps the weapon's greatest test came during Battle of the Bulge in December 1944. When German forces launched their surprise offensive through the Ardennes, American artillery found itself in a desperate defensive role. The 8-inch gun battalions, positioned at corps level, provided long-range fire support that helped stabilize the collapsing front. Their ability to reach deep into German assembly areas, to strike at advancing columns before they reached forward American positions, to conduct counter-battery fire against German heavy guns, proved invaluable. Wehrmacht commanders in the Ardennes reported persistent, accurate American artillery fire that disrupted timetables and inflicted steady casualties. German heavy guns, including the Cannoni 18 batteries committed to support the offensive, found themselves under constant harassment from American artillery that could shoot farther and displace faster. The operational advantage that German planners had counted on catching American forces off guard and exploiting their initial confusion foundered in part against the brutal effectiveness of American firepower. A captured German artillery officer, interrogated in January 1945, provided a telling assessment. Major Klaus Dietrich, commander of a Cannoni 18 battery destroyed during the Ardennes offensive, stated in his interrogation transcript, "Your artillery is not better because of any single gun. Your guns are good, but so are ours. What defeats us is the system, the coordination, the speed of fire direction, the endless supply of ammunition, the mobility of the batteries, and yes, in some cases, the longer range of your heaviest pieces. We cannot compete with this. Our individual gun may match yours technically, but we cannot match your organization and your industry." Dietrich's observation captures a fundamental truth about the 8-inch gun's significance. The weapon itself represented an impressive engineering achievement, but its real impact came from its integration into a larger artillery system that emphasized coordination over individual performance, weight of fire over precision of aim, and systematic destruction over dramatic single shots. The comparison between the 8-inch gun M1 and the 17-centimeter Cannoni 18 reveals much about the different paths American and German military development took during World War II. Both weapons emerged from similar doctrinal requirements, provide corps and army-level artillery capable of engaging targets at extreme range. Both employed sophisticated engineering solutions to achieve unprecedented mobility for weapons of their power. Both required specialized crews and extensive logistics support, yet they differed in crucial ways. The Kanone 18 represented German engineering at its most ambitious, technically brilliant, mechanically sophisticated, capable of exceptional performance in ideal conditions. The dual recoil system exemplified this approach: elegant, effective, and complex. Such sophistication came at costs measured in production numbers, maintenance requirements, and deployment flexibility. Only 338 Kanone 18s ever existed, spread thin across multiple fronts, never concentrated enough to achieve decisive effects. The 8-inch gun M1 embodied American pragmatism. Its designers accepted shorter barrel life, adequate rather than exceptional accuracy, and compromises throughout the design in exchange for manufacturability and reliability. The gun was simpler to produce, easier to maintain, and more forgiving of crew errors. While only 139 were built before Germany's surrender, far fewer than American planners wanted, this still represented 40% of German production, despite America's later start and shorter production run. More telling, American industry built the 8-inch gun while simultaneously producing thousands of other artillery pieces. The 105mm Howitzer M2A1, the backbone of American divisional artillery, reached production numbers exceeding 8,000. The 155mm Howitzer M1 topped 4,000 units. Even the Long Tom, itself a specialized weapon, exceeded 500 examples. American factories churned out artillery in quantities that German planners found incomprehensible. This production disparity extended beyond guns to ammunition, fire control equipment, prime movers, and all the supporting infrastructure that made artillery effective. An American 8-inch gun battery deployed with dedicated ammunition trucks, fire control computers, radio equipment, and enough spare parts to sustain operations indefinitely. A German Kanone 18 battery relied increasingly on improvised logistics, captured equipment, and make-do repairs as the war progressed. The mobility gap widened throughout 1944 and 1945. American 8-inch gun battalions could displace by road at 25 to 35 miles per hour, covering 160 miles in a day under favorable conditions. German heavy artillery, still dependent on horses for much of its movement and limited by aging tractors for its heaviest pieces, struggled to keep pace with the increasingly mobile front lines. This mobility advantage meant American guns could concentrate quickly for major offensives, then disperse to avoid counter-battery fire, then reconcentrate elsewhere, a flexibility that German artillery could rarely match. The end of the war in Europe found 8-inch gun battalions spread across Germany and Austria, their crews having fired thousands of shells in hundreds of engagements. Battery commanders had learned the weapon's quirks and capabilities through hard experience. Optimal firing patterns emerged from trial and error. Crews developed techniques for faster emplacement and displacement. The gun that had entered service with concerns about its reliability and accuracy had proven itself a valuable, if specialized, tool. For Germany, the story of the Kanone 18 ended in rubble and ruin. Of the 338 guns produced, most were destroyed in combat, abandoned during retreats, or captured by Allied forces. A handful survived the war as museum pieces or technical curiosities. The dual recoil system that had seemed so innovative in 1941 became a historical footnote, an example of over-engineering in an era when simpler designs proved more practical. The 8-inch gun's service continued beyond Germany's surrender. During the Korean War, 8-inch gun battalions deployed to provide long-range fire support. The weapon's ability to reach deep into enemy territory, to conduct counter-battery fire against North Korean and Chinese artillery, proved as valuable in the 1950s as it had in the 1940s. The gun remained in American service until eventually replaced by self-propelled variants and more modern systems in later decades. But the weapon's true legacy lies not in its service record or technical specifications. The 8-inch gun M1 represents a turning point in military-industrial thinking, a moment when American approaches to weapons design, emphasizing production efficiency, reliability, and system integration over individual technical brilliance, proved decisively superior to traditional European methods. Hauptmann Friedrich Weber survived the war, surrendering to American forces in May 1945. In his post-war testimony, preserved in Allied intelligence archives, he reflected on his experience with the 8-inch gun. "We knew from the first shells that something had changed. The Americans had always had good artillery, many guns, much ammunition, but this was different. This was one of their guns that was also better than ours. Not just more numerous, but actually superior in its capabilities. It was, I think, the moment when many of us realized that we could not win, that American industry had simply outmatched German engineering. They had built a gun that did everything our best gun did, and then shot 3 miles farther. How do you fight against that?" Weber's question, rhetorical though it was, cuts to the heart of the matter. Germany had entered the war with superior artillery in many categories, with longer reach and better accuracy than Allied pieces. But by 1944, American industry had closed those gaps, and in several cases surpassed German capabilities. The 8-inch gun stood as visible proof that American engineering could match German technical prowess when properly applied and supported by industrial resources that Germany simply couldn't equal. The German examination of captured 8-inch guns, conducted in barn-turned-workshops by artillery officers who'd spent careers studying their craft, must have been sobering. Here was confirmation that everything they'd been told about American limitations was wrong. American guns could shoot farther, American shells hit harder, American logistics kept those guns supplied and mobile, and most damning, American industry could produce such weapons in numbers that, while not overwhelming, were sufficient to matter tactically. The examination reports, dry and technical as they were, effectively admitted defeat in the artillery arms race. Recommendations for German responses filled the final sections of Brenner's report, but they rang hollow even as written. Germany could not redesign its heavy artillery in mid-war. German industry could not suddenly triple production rates while simultaneously building tanks, aircraft, submarines, and everything else the Wehrmacht needed. German logistics could not match American mobility when much of the German army still relied on horses for transport. The 8-inch gun didn't win World War II. No single weapon system did or could. But it exemplified the trends that determined the war's outcome: American industrial might, pragmatic engineering, and systematic integration of technology into effective military doctrine. The gun that German artillery officers initially dismissed as another American piece revealed itself as something more troubling. Evidence that American capabilities exceeded German assumptions in multiple dimensions simultaneously. In museums today, the surviving 8-inch guns sit quietly, their barrels cold, their mechanisms frozen. Plaques detail their specifications, explain their role, note their historical significance. But these static displays capture only the machine, not the moment of recognition when German officers realized their carefully maintained advantages had evaporated. That moment came in different ways for different men. For Hauptmann Weber, it was the whistle of that first shell at Casino. For Oberst Brenner, it was measuring the barrel and calculating the impossible range. For Major Dietrich in his prisoner interrogation, it was the bitter acknowledgement that Germany's best was no longer good enough. The irony would not have been lost on these professional soldiers. Germany had pioneered modern artillery doctrine, had written the textbooks on indirect fire and fire coordination, had built the guns that set standards for the world. Yet in the crucible of total war, it was American industry and American pragmatism that prevailed. The 8-inch gun, designed by committee, built with production efficiency in mind, accepting compromises throughout its engineering, outperformed Germany's technical masterpiece by the simple expedient of shooting farther and being available in greater numbers when it mattered. This reality, more than any single battle or dramatic event, characterized the Second World War's closing years. Germany possessed excellent weapons, skilled soldiers, and sophisticated doctrine. But excellent proved insufficient when opposed by vast industrial capacity, systematic development, and the sheer material abundance that American production provided. The 17-centimeter Cannoni 18 remained a superb artillery piece to the very end. Its accuracy, its range, its mechanical sophistication earned respect from everyone who encountered it. But being superb no longer sufficed when the enemy fielded weapons that were superior, backed by logistics that ensured those weapons remained supplied, mobile, and effectively employed. The German artillery officers who examined those captured 8-inch guns in summer 1944 understood this. Their technical reports, filed through proper channels, arrived at headquarters where staff studied them and filed them away. What could be done? German designers might create a gun that matched or exceeded the American 8-inch piece, but where would Germany find the steel, the machining capacity, the specialized labor to build it in meaningful numbers? And even if such guns could be built, where would Germany find the trucks to tow them, the fuel to move them, the shells to feed them? These questions had no good answers, and everyone knew it. The artillery war in Europe had been lost not in any single engagement, but in the years before the war, when America built factories while Germany built guns, when America trained engineers while Germany trained soldiers, when America prepared for industrial warfare while Germany prepared for swift, decisive campaigns. The 8-inch gun that Hauptmann Weber first heard whistling over Cassino represented all of this, not just a weapon, but a symbol of economic and industrial realities that no amount of German courage or technical skill could overcome. The gun that outranged the Cannoni 18 by 3 miles might as well have outranged it by 300 miles. The gap was not one that Germany could close through effort or ingenuity. It was a gap of industrial capacity, of resource availability, of systemic advantages that compounded with every passing month of the war. In the end, the story of the 8-inch gun and the Cannoni 18 is not really about artillery at all. It's about the nature of modern warfare, where industrial might matters more than individual technical excellence, where production numbers trump performance advantages, where systematic efficiency defeats brilliant sophistication. It's about the moment when German military professionals realized their assumptions about American capabilities had been fundamentally wrong, and the terrible implications of that realization. It's about the morning when the shells started falling from impossible distances, and the careful calculations that had sustained 3 years of warfare suddenly meant nothing at all. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.